Okay. Exam 2 review is after the class today. And before I talk about exam 3 in the review, I would like to talk about exam 3. The exam 3 will be due at the whatever the school said the last day, the final day. Okay? But the problem is something like this. Okay? I'll give you a response surface. Okay? And then in the real world, you don't really know what the response surface looks like, but I'm going to give you the answer. I say the response surface looks like this. And then you start from any square and run an experimental design. And of course, you can, insert shape. Where's shape? Oh, here we go. Okay, so you can say that, I can have an experimental design, start from here, or, let me do this. There is a transparency. Where is it? Okay, whatever. Okay, so then, for example, here's the minimum, right? Right? So you need to basically run the experimental design many, many times to do what? To reach gradually to the minimum. Or the other way around, is you start from somewhere and then find a maximum. In the real world, do you really know where's the minimum, where's the maximum? Of course you don't, right? You don't know what's good for your performance, minimum or maximum. So you need to start some guessing. And I'll teach this and say that what will be a rough estimate, and then basically let you try different versions to find a maximum and minimum. And some problems start easy, but some problem, I call this toilet seat problem, it's very, very hard because you can easily get trapped and not, if your experimental design is not smart enough, you will try several times, and guess what? Every time you'll get trapped in a local. But if your experimental design is too big, then you're gonna miss that. So basically is what? You're just running this ANOVA experimental design many, many times. And since it's many, many times, that's why we'll use SAS. Let SAS help you, you start somewhere and then boom, 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 reach the max. Or boom, 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 reach the min. You follow me? And then that's why the exam will be in SAS. The problem is most people will say, well, I know it's here. But when you start somewhere, and of course you can say that, I'll start from, you're looking for minimum, I look at the graph, I'll say I'll start my experiment right here. One trial, you're done. But the thing is that I'll say that I need you to demonstrate say 3 or 4 iterations, from 3 or 4 different starting points. And at the end, especially these days, okay, when you look for jobs, they're not just interested in minimum and maximum. They don't want to do data mining. They want to understand the landscape. So you need to run this few times to find the locations. Like for this one, I probably would start from the middle, right? Going up, coming down, and then you know that that's a good starting point to investigate something. You guys agree with me? Yeah. For example, how many of you been to DC? Yeah. And there are so many different things to look at DC, right? So if you want to start your tour, a robust starting point, where will be a good, robust starting point? The mall, in the middle, Smithsonian, right? You like science, go sideways. You like politics, go upward. You like history, go downward, right? And you want academics, go to Georgetown, the other way. So there are smart things to do. So I would let you run the SAS, and then at the end, probably come up with something like, okay, now you investigate this enough. Use what you investigate, tell me, or from the SAS, tell me which way is the right way. So you guys see, computationally, the problem is not as, once you use SAS, I'm gonna keep doing SAS today, there's not much like Excel, spreadsheet after spreadsheet is annoying, right? But at the same time, you need to know enough about the computation to take advantage of abuse SAS. Okay, so here are some landscape I can use. I haven't decided which one I'm going to pick. Okay, there are tons of landscape you can use. Some of them, are really torture. Like sinusoidal, oscillate a lot. Means that you get trapped all the time. And how to find the optimum solutions. Okay. And so, yeah, this will be the exam 3, okay? Yeah, make sense? Okay. I already asked you last time. How many of you think that later on you work in a real industry, people really want to see your p-value less than 0.05? What do you think your boss really care about? Make this bigger, make this smaller, so I can make more money, right? End of the story, right? And so the things at the end is operation research, okay? They need evidence. And where the evidence coming from? Some data. And then you need to find a way to get those data going. Okay? Yeah. Okay, SAS time. Last time I already talked about it. SAS, 2 steps. Or at least 2 parts. One part is called data. The other part is called procedure, proc. Okay? And there are tons of different procedure and different data steps. But in this class, we're focusing on few simple steps. Okay? Huh? Oh. No, we're not going to use this part. So we should be, yeah, okay, thank you. I'll be careful. I guess I'll still start from something very simple. Okay, I already did it last time. Okay, and here are the things that not related, but a lot of time, yeah.
Have you posted that on?
Yeah, you have all the SAS code I give you.
Where is it on your campus page?
Yeah. And it was there long before. Okay, so here is the LS for line size, and why we have that, because sometimes you guys want to make your font, your picture a little bigger or a little smaller. So you can say that I can have ls equal to 138. So to be very, very big, okay? And be honest with you, guess how I did it these days? Once I have the output, I print them into a PDF. And then I can save the PDF as an image. And when I copy paste that image into my Word file, I can shrink it, make it big. Okay, for those of you gonna publish something later on, most of the journal, they count word count. But if you post it as a picture, even though there are tons of word, they don't count it as word. And the other beauty of it is that the SAS intentionally have their picture with very, very high resolution. So when you shrink them very small, even the font size is 5 or 4, still legible, okay? Okay, so say options. And the other options I believe you guys would like to use during your final, okay? Here's the options. No date, no page number. I think I forgot how to do that. Well, you guys can, here, go to SAS, find the print options, no page number. And why you want to do that? Because when you have tons of output, right? The page number and the date will make your writings very hard to read. Okay? So I tend to get rid of it. Okay? And I think it's called no number, maybe. Yep, no number. Okay. And then after that, okay, you can have this title, and with this quote unquote. So, this is title line 1. And then if you want to have another title, you can say title title 2. Okay, this is the second line. And for our projects or for your stuff, this is not really that important because you only have one set of procedure to worry about. And when this is a good thing to have, when I work for an insurance company, sometimes I have data from 10, 20 different sites and with different date. I'll get confused. So I'll put a lot of footnote, okay? And I already asked you guys before, whenever you have code, you want to put some notes on your code. What is the common sessions? There are 2 different ways to do the common session. One is have a star. Okay. Some reminder. Okay? And then you can have one more. Some more reminder. And if you really want to have a lot to say, you can just say that, okay, let me block this whole sessions. Okay, see here, only one line common is star and semicolon. And if you want to block a lot of stuff, it's /star. And inside you can, now I'm getting wordy. Okay, and then you can say a lot of stuff. Okay, and those got nothing to do with DOE. It's just SAS. What was that? Okay, data procedure. Okay, I can say, oh, this data is for motor, for cement. Okay, input formula 1, formula 2. The differences is the diff is formula 1 and formula 2. Okay, and then when you run this, you can say normal means give me a QQ plot, and then check the normality and plot and just check the histogram and the whisker plot. Okay, so this is almost like your pair t-test. And when you can use this for your residual, you can plot your residual this way. Okay, and when you run, yeah, it will show the QQ, the quantile, the univariate, and so on. Okay? And it's okay, and let me start from a more complex experiment. I already done a single trial experiment. Let's say we're gonna do a blocking experiment. Okay, so if I want to have let me run a blocking experiment. So here's a blocking experiment in the BIBD. Okay, anybody? Did you find a BIBD? Okay, yeah, I'm not trying to hide anything, okay? Whatever I can get, sometimes I just give you more than I should. It's all in there, okay? So here, options, no date, no number, and run it in the center. Line size 80, page size 60. None of this is important, okay? You can even block them. You don't want to use them. This is just try to make the printout SAS page looks in different configurations. Like I said, I usually run the things, let it run, and then just clip on the PDF and use it. Title, okay, and is a randomized block design. So data is called RCB. Input, treatment, 4 treatments, blocks, 4 blocks, and then performance. Here is the term. Okay, if you don't have ampersand, okay? If you don't have ampersand, the ampersand means that read the data, keep reading it, follow this treatment block performance. So people watch me, okay? If I don't have this ampersand, let me try to show you this way. So I make the data, say, look like this. That means what? Every data line, I have 2 conditions, right? 2 treatment block. And if you have something look like this, okay? Since you have the ampersand sign, means SAS will do what? Treatment 1, block 1, performance 73. Treatment 1, block 2, performance this one. So just bear with me for 1 second. You guys see what I did? I just blocked the entire procedure after, because I just want to show you the proc print statement. Okay, people look at the proc print, okay? Even though this looks very irregular, but if I plot them, they still go like this. So, in other words, is that the ampersand sign is very useful when you have the data, from different source, but you just follow their sequence, okay? And second thing is this, okay? Okay, so now if I don't have the ampersand sign, you have to make the data look like this. Okay, but with ampersand doesn't really matter. Just read. Okay. One more statement before proc print. Also simple procedure. And don't worry, okay? I'm not gonna say that, oh, go read the manual, there are tons of stuff. Well, I will say that. There are tons of stuff on the manual, go read the manual. But everything I think is useful to you, okay, I will introduce you. So we're not gonna have tons of statement I'm gonna show you. I'm only show you the statement relevant to DOE class. And I'm going to show you only the stuff that you done Excel with it. So here, another statement is called proc sort. And usually I'll put the proc print statement before, proc sort statement before proc print statement. I'll say proc sort. Sort by, you guys want to sort by treatment or sort by block? And you can do Excel, first sort by this, then sort by this. Especially when you have large, so let's just do it this way. Sort by treatment by block. Okay, that will sort by treatment and by block. And then after that, okay, we can run the procedure, okay? Before we do that, let me just block this, just print one more time. Okay. Oh, I need to have a run. Without a run statement, it doesn't run. Okay, so, huh? Oh.
What did you put in here?
Huh?
What did you just click to run?
Oh, the little guy up here. Yeah. And on the logs, if I don't want to read them, I just go here, clear all, get rid of it. Okay? And let me just. Let me get rid of it. Something is wrong. Okay. Let me get rid of. I think when I messed it with the data, I made a. Okay, so 1, 2, 3, 1, 2, 3, 4, and now might as well just do it once because I don't remember. And just go here to SAS. Okay, just say that proc sort. Okay, in SAS. And SAS procedure will show you all the documentation for SAS. Okay, sort data by, that's what I did. Where did I do wrong?
I don't think you had the data in there.
I shouldn't need to because I only have one set of data. But, okay, I'll do it your way. Sort by, sort data equal to RCB. Okay? One, two. Okay, let's do it again. Yeah. Sort.
What's in between the data and the RCB?
Huh? Oh, data equal to, yeah. Because we name our data RCB, okay? and sort by, this time say sort by block. Okay, so I'll have block 1, block 2, block 3, block 4. Okay? Okay. Now, this is done. Let's block them, because that's not the things I want to, that's not experimental design, right? Okay, so proc, GOM, general linear model. Okay, remember I told you guys what's the difference between GOM with the class statement and without the class statement. With the class statement is the central station, subway stations approach. Without the class statement is the regressions approach. So if I run this without class, it will be regression approach. Okay, next. So I have my performance equal to treatment and block. Okay, and after that, there are several SS term or EE term. That's the error term and the sum of square. And P stands for predictions. So let's go back to the SAS manual. This time, proc GOM. Okay, SAS. Okay. And you will see the GOM, no print alpha data. That's not the part I want to show. Okay. Random statement too early. Okay, you know what? Let me run it and then I'll explain it. Okay, so we run data, class, model. First thing first, suppose you say that, Simon, you're giving me too much information. I don't like this. Okay, so let's do this. And I'll come back. Okay, so you can block this. I'll just copy, paste. So let me just do the stuff that you're familiar with. No error term, no partition of sum of square. Okay? Just give me a prediction. And then, after this, okay, SAS is doing something I consider, give you 4 cents of security or illegal. Remember, I told you guys you're not supposed to do multiple comparison unless all your sum of square are significant and or your residuals are legal, right? And then you can run that. But SAS basically said that, you know what, that's your problem. You figure it out. So SAS basically said, I don't care if you have significant or not significant. I'm going to do multiple comparison for you. I don't care if the residual is normal or not normal, is autocorrelated or not autocorrelated. I'm going to run the multiple comparison with you. So while SAS is a software, he can say that I don't care. I just run, right? But for you guys writing your capstone project or your senior projects, you need to keep this in mind. That is not science. Science should be what? First, significant, and every procedure, every step, the evidence collection is legal. Then you do multiple comparison. But anyway, we're doing multiple comparison. When you do the multiple comparison, here are the couple other one you should consider. One is SNK test. Just put SNK. We already talked about it. SNK is the most detailed test. Okay? So in other words, is that usually if SNK multiple comparison pass, you probably can pass other tests. SNK is the most detailed one. And then after that, you can do a Sheffey. Okay? And then LSD. And actually, you don't need to write alpha equal to 0.05 because they will set up the alpha level, the default level, alpha level is 0.05. Usually what is the alpha level you need to set up is, say 0.00005, right? You're running this for Elon Musk, SpaceX projects that, one failure is $1 billion. So you need to double check, triple check. Okay, otherwise this is good enough. Okay, so usually if you run it this way, performance treatment, significant predictions, check the error term, okay, and you run it this way. Okay, it will give you first the ANOVA table, okay, and then 4 treatment, 4 blocks, okay, and here's the part that actually where the sum of square and error term coming from. The SAS procedure actually consider there are several different ways you can build up your sum of square partitions. The way how I show you guys is equal space way. In reality, you can have what we call pulling up or pulling down. And what is pulling up or pulling down? Here. Let's start from something. Say I'm building a regression. And I'm building a regression. I can start from what? A full model. Say I'm using 4 explanation variable. X, A, B, C, D. So Y is a regression of A, B, C, D, right? And then when you build a sum of square, you basically can do it this way. First, a full model, A, B, C, D. And then you run a model that without A, without B, without C, without D. So for example, I use a model of A, B, C, D minus A, B, C. Okay? What does that tell you? That means that full model versus a partial model with only ABC, how much differences are there? Then I can have a full model BCD. So that will be the contribution of the full model and the partial model without A, without B. You guys agree? So that's the 4 model down. And then there's a second way you can do this is what? The sequential way. The sequential way actually is the way I kind of keep talking about in this class. How we run this, I'll start with the experiment running the ANOVA model. First, sum of square A, sum of square with B, sum of square with C, sum of square with D. So I will have 4 simple models. Agree? For those 4 simple models, what do I care? I'll say that, okay, now, which one is the biggest one? So I can have A, I can have B, I can have C, I can have D. Let's say C is the biggest one. Then after I have C, then I say, okay, now I already have C. What else can I have to make this model better? So I'll start from the largest sum of square, C. And then now adding the second term in. So it could be what? AC, BC, CD, right? And then you check among adding that extra stuff, which one is the best one to have, okay? Then you said, oh, BC introduced a lot more. Means that whatever, I'm sorry, we originally have C, right? So C explained a lot. So I already say, C, you're the king, you're in. After the king in, you said, it's almost like building a basketball team. The best one in, Then you say that, oh, let me test you here a little bit, see if you're with me. A, B, C, D, let's just say that C is the best. The second best, say, is D. You guys hear me? C, D, and then A, B. Now, what will be the first one in? The largest one I want to be in is C, right? So if the largest one in is C, based on this sequence, the second largest one is D. How many of you agree? You guys follow me? Here, let me write it down in Excel, because SAS is easy. It's just print it out for you. But the interpretation, SAS did the computation for you, but the explanation. So let's just say the sum of square right now. C is the best. D is the second, A and B. So the primary model is C in first. So now, so here is the primary model, prime. Only using this. Now if I have this two-way model, okay, for sum of square, how many of you think that since the first one is C, second one is D, so the best two-way model with two variables in there should be CD? How many of you think that's the case?
I want to say yes, but I feel like it's a trick question.
Who said that? Good job. But of course, then I don't want to just say that, hey, I trick you, right? I need you to think why. Here's the deal. C is very, very good. D is very, very good. But is it possible C and D are explaining the same things? So whatever C good at, D also good at. So in other words, C-D interactions, very, very strong. So in other words, D can contribute a lot of stuff C can contribute. So adding D into the model explain a lot of stuff already explained by C. Then CD may not be good. Then it could be CA, could be CB. So you guys follow me? I can have CA is better than CD. Yeah, and you guys should ask, how come 1-3 combination is better than 1-2 combinations? You guys like to play basketball again? Sometimes it's the case, right? You like to have a triple shot, and your partner like to do the same things. So put you two in the same team actually is terrible things, because you're gonna compete internally for something everybody can do. So in this case, I'll say that get rid of CD and use CA because D is better. CA is better. Now, suppose that's the case, okay? Then we can end up with three-way model. Same thing can happen is that, okay, now you think that, well, how about now? Can I have CDA? Not necessarily the case. Could be CDB. And it's kind of like, oh, those two are doing the same things that we already have. So this is basically start talking about sequentially. Small team, add something in. I don't include any newcomer unless he can contribute something unique. You follow me? So C, D, and then CA could be CAB. Okay, so this is the reason we check those sum of square. Okay, and then this way of checking the sum of square sequentially is by doing what? Adding stuff in. Okay, SAS can do it the opposite way. How they did it is they start from a full model. Okay, this is called what do you call that? Yeah, one is pulling up, the other one is pushing down. Pushing down means what? I start from A, B, C, D. Everybody's in. Okay? And now we say we want to get rid of one person. And we said that, hey, economics is not doing well, inflation is coming, we don't need all the manpower. We can get rid of one. Who should we get rid of? So you start checking the three-way interactions, okay? The ABC, how many three-way interactions you can have? 4, right? ABC, BCD, ACD, well, BCD, yeah.
ABD.
ABD? Yeah, okay. Yeah, and every time when you do this, it's kind of like, okay, what's the difference between full model and this? Differences means that, hey, with or without you in the full team, how much difference? If we find that, the smallest difference means what? Get rid of that one, we can retain all the sum of square without too much sacrifice. That means we have one guy is expendable. You guys follow me? Okay. So that's how SAS tried to do this pulling up, pushing down sum of square. Okay? And actually, talking about this, in the homework, okay, remember, I always ask you guys have all the effect, bubble sort, and then find the elbow point. Why we're doing that? We're doing the same things, right? SAS or Excel, sooner or later, it's just a bunch of contribution. We're looking for the one expendable. And said, okay, hey, with you or without you, how much difference? And that's the other way to evaluate the sum of square. Okay, let's go back to the procedure then. Okay, this time, say I want to run the procedure. So keep the procedure, okay, and then get rid of my model statement. See that? I'm not doing anything fancy, okay? Just run the sum of square. Okay, and here let me get rid of all the yada yada. Okay, so let's run it. Little guy, run. Okay, so here is the predictions and the residual, and you guys know how to do that in Excel, so I'm not going to show. And here is showing that, okay, every block, okay, see, first things first, okay, performance 1, 2, 3, 4. Which one is if I want looking for the big one, which one's the best? 4, right? But at the same time, looking at the block, do you think there's a blocking effect? Yeah. Red block is higher than the blue block, and blue block's higher than the brown block, higher than the green blocks. And then here's the distributions. And for the multiple comparison, okay, the multiple comparison, okay, this is SAS writing it. This is old days, okay. This is from my Fortran days, 40 years ago. Here is saying that, okay, I can group number 4 and 1 in one group. So it's 4 and 1 into the A group. And then 1, 3, 2 can be in a group B. So in other words, is that 4, 1 or 1, 3, 2 is the multiple comparison. I cannot tell the difference between 1 and 4. I cannot tell the difference between 1 and 3, 3 and 2. Everybody understand the multiple comparison view? They call it mean comparison, right? Multiple comparison, group by group. Okay, and here we run this using SNK tests. People can tell. Okay, SNK 1, 4, 1, 3 in one group, 1, 3, 2 in another groups. Okay. And yeah, this is just different multiple comparison. Okay, now look at the sum of square using different policy. Okay, and here You know what? This should be in my notes. Yeah, here we go. Right here. In the notes, type of sum of square in SAS. Okay? And for those of you think that, well, we're not going to have this in the exam, I don't care. I would say that maybe, but you might need to learn this one day. Okay. So here are the type 1 of sum of square. Watch here. First, start from A model. This is a sequential model. Why A in first? A is the biggest sum of square. A in first. And then A, B in, and then talk about A, B interactions. So this is a start from the biggest one, and then add one in. Okay? And what is sequential model? Sequential model basically doing this. Okay? Hey, B in, if I add A in, how much differences can I add? A in, if I add B in, how much extra sum of square can I get? Or, central station, A in, B in, do I want to have AB interaction in? If AB interaction in, how much extra I can get? Okay? So you guys see this, it's always start from something big. And then, do I want to bring something else? Okay? So in other words, you can imagine that you and your partner start a company, and making $1 million of money. Okay? And your partner say, hey, I would like to include my cousins into our partnership. Would you say, sure, since we're a good friend, good partner, you should include your cousin? Or you would say that, no, I don't want your cousin. What should be the right sum of square statement we're going to have? I'm in, you in, we know your contribution, you know my contribution. Now, adding this extra term in, so what? How much benefit can we get? And how much it's going to cost us? Right? So, a lot of time, actually, my policy gets, if I add someone in, it's the benefits, their benefit can be C, but it's not much. Do you think I like to add people or I don't like to add people? I don't like to add people because you guys know what is sunk cost? What is sunk cost? Once it's in, it's hard to get rid of. So, unless you really know. Okay? Now, let's talk about the balanced partial and orthogonal partial. First, look at the type 3 partial is, okay, I have three things, right? A, B, and AB interactions. When you look at a partial, it's always what? Having the other two, looking for the third one. So, A, B, AB interactions, always have two in, and say that, okay, we have this two. What is the benefit of adding another one in? And the other one is, balanced partial is, okay, where start from, AB interaction, AB interactions with A with B, or A and B, check for AB interactions. Okay, among the four, okay, Guess which one is the one I usually used? Or the one I like to use? Based on, so far, my brainwash, I always start from the sequential one. I like to start from only one guy in, one-man company. And one-man company find the most useful A, B, C, D something. And then once I find the best, then I start saying that, do I really want to have another partner? What can I get? What can I get? And what's the benefit of start from sequential? This way. That means that if you, for some reason, got stopped to run the experiment or due to time, due to budget, start at any time. What do you know? It's up till that point, you still have the best you can get. You follow me? So, yes, this sequential principle is what I said about when you go for the buffet. Always start from the surf and turf. Always start from the steak and the lobster, the most expensive stuff. Never go to a buffet, start from, the cheap salad and soup. You want to do salad and soup, you can do it at home. You go to, a nice buffet place, especially expensive. Why? Say, in the middle of the buffet, earthquake, right? They said, oh, we need to evacuate, fire, we need to evacuate. When you evacuate, at least you already have the most expensive stuff. You don't feel, man, I pay so much for very, very little. So here is my argument why I always start from sequential. Biggest one, second biggest one, okay? And there's a name for this procedure, okay? Put that down, because it's really is an algorithm. It's called greedy algorithm. Greedy, G-R-E-E-D-Y, okay? I always run my experimental design, data mining, whatever problem I deal with. I use greedy approach, okay? Now, if you have tons of money, you can start using the balanced, orthogonal, partial approach. I run everything's in a sequential way, okay? So here they will show you the sum of square for type 1, type 2, type 3, type 4, basically sequential, partial, okay? And yeah. And then you can see all the plots, okay? Oh, shoot. Shouldn't stop it. Okay, and yeah, let me run something. Okay, let's run a Latin square. Okay, let's run a regular Latin. Okay, so in a Latin square design, people, because I have ampersand, that's why I can run this row column treatment performance in this way. Otherwise, I need to run what? 1, 2, 3, 4, 1, 2, 3, 4, column by column. Okay? So far, so good? Okay? Options, yada yada, data, performance. Okay? And here, I have a performance equal to performance minus 25. And let me write another one for you to play with. Okay? So suppose that for some reason, remember in our homework, I have performance, perform, equal to log, or ln, yeah, I think it's log. Log perform. What does that mean? Means that I want to take log to get rid of the variations. Oh, one more. You can put a label for every term. So if you put a label, when they print out, they print very, very detailed. Okay? They won't print row, column, they'll print batches of all the stuff. But if you actually run this, you like to make the table concise, I will just run it without a label. Because if you run it without a label, what's the benefit? You can write all the label statement okay, in your text and make it really concise. Okay, so far so good? Huh? Yeah, one more is, I told you guys, I'm an old guy, so I use cards for punch cards. You don't like cards, you can just write data lines. Okay? SAS treat data lines and that as the same things. And then, whenever I see ampersand, I like to run a proc print. So I make sure that the data looks like my data set. So class, okay, equal to all this. Okay, you guys find your SAS Latin? Okay, so yeah, at least I give you a version can run and keep always can re-download whatever I have. And then you just monkey around, say, I don't want a multiple comparison. You just block the multiple comparison. Or you want to keep the multiple comparison. You don't block it. Okay? Everybody good? Yeah. And then you run. Okay, so now, first, this should be the same as your Excel table, except that they just treat them as a transaction after transactions. Okay? And of course, you can have a sort them by treatment, sort them by whatever. Okay, and remember your homework. Totally, if you only have the car, 3 degrees of freedom. Remember exam 2, exam 1? And then include column, another 3 degrees of freedom. Include the diagonal, so 3 by 3 by 3, so you take all your degrees of freedom away. Oh, I'm sorry, 4 by 5, 5, 5, 4, 4, 4. Okay, and when you've done this, you can have your ANOVA table built. Okay, and one more. Okay, for the concept of this type 1, type 2, type 3, I don't need you to memorize it, but I need you to understand the concept. Okay? Everybody visualize what is in the buffet place, eat the big one first, right? Everybody have this orthogonal is that, okay, everybody's in, but at the Christmas time, we want to lay off one person. Who can we get rid of? You get rid of the person you consider the least effect on your team. So one is, getting rid of people one by one. One is adding people one by one. Okay? And you need to visualize this all the time. Is why I like to, at least this is my experience when I work for the industry. Adding people in sequentially is a lot safer, economical than getting rid of people. Just imagine during your buffet, earthquake, It says that, okay, we have to shut down. You have to go now. At least you have one big bite of the lobster tail. You have one big bite of the juicy steak. But if you start from salad, from other stuff, then tough, right? Okay, so sum of square, the residual, and you can play with the residual, okay? And use the residual to run the residual plot, okay? Oh, one more, okay? On the Durbin-Watson test, okay? If you want to have the Durbin-Watson test, here is the things you need to add in, okay? Let me see if I can do that. Too much work. If I want to have this, I need to add another term in front of it. Let's just say that I add another term. It's called run. Okay? Means that I did this first, second, third, and so the number should be from here, you know. Okay, let me fake the run for once. Okay, you have the procedure. You guys know how to turn the SAS data into data, text to column. You can use fixed, limit, or denominated. I'll use denominated, space, finish, okay? And then after that, you basically just insert, 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 insert. And then have the,
You have 5.
huh? That was quick. Okay, and then you have the run number. So when you run the whole things, you can have the residual and then compare, okay? I will have something relate to the legal test, you know, Durbin-Watson or equal Bartlett test, at least something relate to your exam. Why? Because it's important that you guys, when you finish your senior project or your capstone projects, you know how to defend your observation in court. You don't want to tell people, oh, how did I cook the number? I don't remember. Okay? And yeah, let me see if I can run one more. Factorial design. Oh, shoot. Yeah, let me see if I have one here. Okay. Okay, here is one of your procedure. And see here, I have 2 GOM. This is in the, okay. 1 GOM, I write a model like this. This is a complete model, and this is a reduced model. What do I mean by that? This statement was the pipe, okay? Pipe means the interaction between the two. So let me write it down here, okay? Here means that consider all the possible interactions. So Y pipe A, pipe B, pipe C equal to A effects in, B effects in, C effects in, AB interaction is in, AC interaction is in, BC interaction is in, and then three-way interaction is in. Okay? So this is A pipe, B pipe, C really means everybody's in. So people, anybody tell me Y model equal to A, B, C pipe D. What does this model mean? Anybody?
The A effect, the B effect, and then the C and D interactions.
C and D interaction or C and D main effect and interaction?
Main effect and interactions.
Yeah, so just remember, whenever you have the pipe, that means that expand everything, okay? And for this homework, you guys play with it because you should get the same output. If you don't get the same output, SAS is wrong. Okay, let me go talk to